As the leading platform as a service product, OpenShift is constantly pushing the limits on what is possible when architecting applications for the cloud. Things that used to be considered a limitation of a platform as a service are now possible, and more traditional services can now get the flexibility and ease of running in OpenShift. Before we discuss how applications can be architectured for high availability in OpenShift, let's look a bit closer at the core architecture of OpenShift. OpenShift Enterprise version 3 manages workloads on multiple hosts that could be physical or virtual hosts. If you need more computing power and more memory, additional hosts can be added without disrupting the current workloads. Pods in OpenShift are orchestrated by Kubernetes and can, for example, automatically restart a pod that has stopped working. It can also move workloads between the hosts to spread the workload to achieve high availability and even load. Within a pod, there are one or more Docker containers which encapsulates the middleware runtime. The runtime can, for example, be a Java EE platform, Node.js, Tomcat, or almost anything that can run on Linux. Most platform as a service products requires each service to be isolated. However, traditionally architected services are often split into different tiers that can scale independent of each other. Within a project in OpenShift, it's possible to separate, for example, the data from the application. Pods can communicate with each other, making it possible to define services using tiers. To route incoming traffic to the service endpoint, there is also an HA router in OpenShift. The router can also work as a load balancer when applications are scaled. In the OpenShift console, we can see which services our project is composed of. In this example, our to-do application consists of one Java EE service called To-do app and one data store called To-do DS. The To-do app has a route configured, which means that our application is publicly available using this host name. The example application is running on JBoss Enterprise Application Platform and can via environment variables connect to the data store. For illustration purposes, we are using a two-tier architecture, but the same principles can be used for a multi-tiered architecture. One of the benefits of a tiered architecture is the possibility to scale different tiers independently for either high availability or performance reasons. Scaling a traditional data source like a database are not easy, while an in-memory data store like JBoss Data Grid can easily scale to ensure performance and high availability. Scaling a service to use multiple pods in OpenShift can either be part of your deployment definition or manual via console or command line interface, or automatically based on load. Thank you for watching this video.